Hello and welcome to MATLAB programming for numerical computations. We are in week number 4. In this week, we are covering linear equations. In lecture 4.2, we are going to cover one of the most popular method for solving linear equations, which is known as Gauss elimination. In today's lecture, we are going to use what is known as the naive Gauss elimination technique. Okay, so let's take an example in order to show how we are going to solve this problem. This example is from the Computational Techniques video course, Module 3, Part 2, the link for which is given over here. Okay, so these are three equations in three unknowns. The three unknowns are x1, x2 and x3. Together they form a vector which is a column vector containing 3 rows. Okay, we will write this equation as Ax equal to B, where A matrix is going to be nothing but 1, 1, 1, 2, 1, 3, 3, 4, minus 2, and our B vector is going to be 4, 7, 9. In the previous lecture, we have seen that we can use MATLAB's powerful linear algebra suite in order to find the solution x, either using inverse of A multiplied by B or the backslash command. What we are going to do today is to use the Gauss elimination technique in order to solve this linear equation. Okay, and let's say edit Gauss elim, and this is the one that we are going to create in order to solve the problem using Gauss elimination. Let's go on and look at the problem. Our A is 1, 1, 1, 2, 1, 3. Let's write that down. A is 1, 1, 1, 2, 1, 2, 1, 3, and 3, 4, minus 2. 2, 1, 3, 3, 4, minus 2. Our B matrix is nothing but, let's go back and see, 4, 7, 9. B is 4, semicolon 7, semicolon 9. Okay, let's save this, let's run this. We get A and B, and our x is going to be nothing but A backslash B, and that's our x, which is 1, 2, 1. So that's the solution to our problem using MATLAB's backslash command. Okay, what we want to do is to solve this problem using Gauss elimination. So the first step in Gauss elimination is to create an augmented matrix. So let's go ahead and do that. Let's make comments first. Solve Ax equal to B, naive Gauss elimination. Okay, and augmented matrix AB equal to A comma B, and we'll end this with a semicolon. Okay, let's go back. Okay, now at each step Ai is the pivot element. So first we will have A11 as the pivot element, then we will have A22 as the pivot element, and finally A33 as a pivot element. We don't have to do anything with A33, mainly because A33, or rather column row number 3 is the last row. So let's actually do this. A11 as pivot element. Okay, so we'll have a set of computations with that. We'll have a set of computations with A2 comma 2 as pivot element, and with A3 comma 3 as pivot element. Okay, let's say Gauss elimination. Notice that when I've used 2 percentage signs, this has formed a section in this particular code. Okay, I'll just put enter over here. Okay, now we are ready to let's do the next steps. So what's the step with Aii as the pivot element? So let's say A11 as the pivot element. We want to create zeros in the pivot column, which means in column number 1. So column 1 over here is basically 2, 1, 3. So what we are going to do is we are going to subtract 2 times row 1 from row number 2. So we need to use row operations. Row 2, the new row 2 is going to be row 2, the old row 2, minus alpha times row 1 where alpha is A21 divided by A11. A21, which is 2, divided by A11, which is 1. So that's going to give alpha as equal to 2, and row 2 minus 2 times row 1 is going to be our first step. So let's do that in MATLAB, saying alpha equal to A2 comma 1, that's the second row, first column, divided by A1 comma 1. Okay, let's go back and see. That's exactly what we had. Alpha ij is going to be equal to AJI divided by AII. So A21 divided by A11, and then A31 divided by A11. Okay, so that's going to be our alpha. Our row 2 equal to row 2 minus alpha times row 1. Okay, this is not a correct way. So how do we get the row? How are we going to get the row? And we are going to get the row of the AB matrix, and the way we are going to do that, let's actually copy paste this and yeah, so we have this AB matrix. So how are we going to get row number 2? Row number 2 of AB is nothing but row 2 comma colon. The entire row number 2 will be extracted by this command. This is what we get. So this is going to be row 2. What is row 1? Row 1 is AB 1 comma colon. Okay, so what is alpha multiplied by row 1? Alpha multiplied by row 1 is going to be nothing but 2 multiplied by AB 1 comma colon. And when we do that, that's exactly what we get. So this is 2 multiplied by row 1. What we want to do is row 2 minus 2 multiplied by row 1 and assign it to row 2. So AB 2 comma colon is going to be equal to AB 2 comma colon, which means row 2 equal to row 2 minus alpha multiplied by row 1, and row 1 was AB 1 comma colon. Right, this is row 1, which is exactly what I have written over here. Alpha value is 2. This is exactly what I have written over here. Row 2 is AB2 comma colon, which is exactly what I have written over here, and that expression is being assigned to AB2 comma colon. So let me cut this, go back over here and paste this. So this is going to be nothing but row 2 minus alpha times row 1. Okay, and that's cool with us. Next, what we want to do is we want to repeat that with row 3. As we have seen over here, we use the pivot elements to create zeros in the entire pivot column. Entire column 1, we are going to use row 1 in order to create 0 over here as well as 0 over here. Okay, so we need to now repeat that for row number 2, and the way we are going to do that is nothing but alpha now is going to be a 3 comma 2 divided by 3 comma 1 divided by A1 comma 1. Note that only the row number is changing. Row number has changed from 2 to 3, and we change it from 2 to 3 over here, and minus alpha multiplied by row number 1. So it's row 3 equal to row 3 minus alpha times row 1. So that is all the computation required with A11 as the pivot element, and we are done over here. So that's the first step. Now we need to repeat that for column number 2. So what now, after at the end of this, what we are going to get is we are going to get 1 1 1. This guy is going to be 0, this guy is going to be a modified number, and so on and so forth. This is again going to be 0, and these we are going to have some numbers. Let's do this. Let's save this and just run it and see what value of AB we are getting and if we are getting any errors. Okay, cool. So we do not have any errors. Let's clear the screen and type AB. Okay, so what we have done at the end of the first step is, with the A11 as the pivot element, we have obtained 0 in that pivot column. In column number 1, in row 2, 3 and so on, we have obtained zeros over here. Okay, so that's the first step. Now the second step is going to be to convert this as 0 using A22 as the pivot element. We are going to use row operations with A22 as the pivot element, and let's go back to MATLAB and let's do that. In this case, now alpha is going to be something divided by A2 comma 2. What's that something gonna be? That's gonna be row number 3, right? What we want to do over here is we want to use row 2 in order to get this guy equal to 0. So alpha is going to be this guy divided by this guy. So this is A3 comma 2 divided by A2 comma 2. So this is A3 comma 2. Okay, again keeping up with the equations that we had seen a minute before. So that's the value of alpha over here, and our value of AB 3 comma colon is going to be nothing but AB 3 comma colon minus alpha multiplied by AB. Now this time it's 2 comma colon. Why? Because our equation with A22 as the pivot element was R3 minus alpha times R2. Okay, so R3 is this guy equal to R3 minus alpha times R2, and that's what we get over here. So let's save this and run this and see what we get with our matrix AB. Okay, oops, there is something wrong, and let's go back and check what exactly did we do wrong. Okay, alpha is going to be equal to I'm sorry, this is a problem. I should be using AB over here and not A. Okay, so shift, yeah, everything I need to change, right? And the alpha over here also has to be AB because we are working with the augmented matrix. Okay, because this is in the lower triangular form, we don't really need to do anything with the pivot element A33. So oops, yeah, let me go over here and delete this part with pivot element, and this is the end of our Gauss elimination. We are done with Gauss elimination over here. Why did we take just 2 steps? Because we had a 3 by 3 matrix. Okay, next step is going to be back substitution. Okay, now yes, with respect to back substitution, what we do is we have our last equation as, if we go back to MATLAB and check this, our last equation is minus 4x3 equal to minus 4. So x3 is just going to be this guy divided by this guy. Okay, so our x3 is going to be equal to 1. Okay, then we go on to the second last equation. The second last equation is minus 1x2 plus 1 multiplied by x3 equal to minus 1. We take this on to the right hand side and divide by A22, and that is going to be our solution for x2, and then we use x2 and x3 in order to find x1. That's the procedure that we are going to use. So let's do that. So we are going to do x, so x initialize our solution. Okay, so our x3 is going to be nothing but AB end, sorry, AB 3 comma end, which is the last, end basically means the last column, and third row. So AB 3 comma end divided by AB 3 comma 3. That's the value of x3, right? Again, what do we get with respect to x3 is AB 3 comma 3 is the denominator and AB 3 comma end is the numerator. AB 3 comma end is the numerator and AB 3 comma 3 is the denominator. That's our x3. Our x2 is going to be nothing but AB 2 comma end, right? AB row 2 and last column, so AB 2 comma end minus AB 2 comma 3 multiplied by x3. Okay, that is going to be the numerator, so we will put the numerator in brackets. Okay, divided by AB 2 comma 2. That's going to be our x2, and our x1 is going to be, let's just copy this, and we'll have to change from 2 to 1 everywhere, and everything else remains the same. So 1 comma end minus ab 2 comma 3 multiplied by x3 will change to ab 1 comma 3 multiplied by x3, and we will, to this we are going to add ab 1 comma 2 multiplied by x2, 1 comma 2 multiplied by x2. Okay, so let's see what we have done. What we have done over here is the first guy, x1 is going to be ab 1 comma end minus ab 1 comma 3 multiplied by x3 minus ab 1 comma 2 multiplied by x2, and that's really what we have done over here in our MATLAB. Okay, and that will give us the solution once I change the denominator also. Okay, keep in mind that I have an inner bracket over here and then an outer bracket over here. Okay, we save this, we run this, and we check whether the solutions are met or not. Our value of x is 1 2 1, which was the same as a backslash b. So yes, our Gauss elimination is working to the way we desire it to work. Okay, now let's spend some time in order to make this better. What we mean by this is that MATLAB has a very powerful linear algebra set of tools, and we don't really need to write this in the way we have written it right now. What we need to do is we need to put it in a loop. Okay, so first of all, let's look at this equation. Okay, let me copy this, the numerator that was in the brackets, and paste it over here. Let me just put some spaces so that it becomes a little bit easy for us to check. Okay, so we have ab1 comma end minus a bunch of things. Okay, so let's keep ab1 comma end on its own, we don't have to worry about that part. Let's look at the thing that was there in the brackets, that was ab1 comma 3 multiplied by x3 plus ab1 comma 2 multiplied by x2. So if I were to write ab1 comma 2 to 3, what I'm gonna get is the two guys, so ab 1 comma 2 and ab 1 comma 3. Okay, if I write x 2 colon 3, I'm gonna get now a vector which is a column vector, and if I multiply these two, what I'm going to get is ab 1 comma 2 multiplied by x2 plus ab 1 comma 3 multiplied by x3, which is exactly what we had over here. Okay, so let me just multiply this guy with this guy. Okay, and that's going to be ab 1 comma 2 to 3 multiplied by x 2 to 3, and we want to check whether the result is same as this guy, that is whether the result is equal to 3 or not. So let me press enter, and we actually find yes, that's absolutely what we get. So let me go over here, and I'm going to change the thing in the bracket to what we had written in the command prompt. The command prompt, what we had written is this, copy it and paste it over here. Okay, and that is going to be our value of x1. Okay, now if that is value of x1, this is, if you see, it's 1 plus 2 to 3. Okay, so we will just write it as, sorry, 1 plus 1, okay, to n, and we will go up and we will write n equal to 3. We have 3 equations, so why we write it over here, we'll actually take this and put it right at the top. Okay, so 1 plus 1 to n and 1 plus 1 to n, okay, divided by ab 1 comma 1. Likewise, what we are going to do is ab 2 comma 2 plus 1 to n multiplied by ab 2 plus 1 to n. Okay, why we are writing it in this way? Because now we have this x going from 3 to 3, and that is good enough for us. Okay, let's put this in a loop for I equal to 2 2 in step of minus 1 to 1 and right, and this is gonna be I. Okay, I'm replacing 2 with i's over here. Okay, everywhere where there is 2, I'm replacing it with I. Okay, same thing I'm going to do over here, but everywhere there is 1, I'm going to replace that with I. Okay, now you compare these two. What we will see is that these two expressions are exactly the same. That's how we write that's the results in a loop. Okay, as a matter of fact, if we were to do this for x3, what we are going to get is ab 3 comma end minus ab 3 comma 3 plus 1 4 to 3, and 4 to 3 is null, so 4 to 3 is going to be nothing, so it's going to be just ab minus nothing divided by ab3 comma 3. Okay, so I will delete this and I will change this to 3 and Gauss LM. Okay, and we see our x is exactly the same as we got earlier. With that, we come to the end of lecture 4.2, and I will see you in the next lecture. Thanks and bye.